So our question number 1, complex number. From complex number you will get two VSAQs. So under question number 1, our first question is find the square root of 7 plus 24i. So we have to find square root of 7 plus 24i. So what about the square root formula? Any complex number that is in the form of a plus ib, its square root is root over a plus ib equals to plus or minus under root r plus a by 2 comma I times of under root r minus a by 2, where r equals to root over a square plus b square if b greater than 0. If b is positive we have to use plus I, if b is negative we have to use minus I. Okay, so if you compare here value of r, so what about a is 7, so 7 sevens are 49, b is 24, 24s are 576, summation is 625. And what about square root of 625? That is 25. So here r value is 25. Now we have to find square root using the formula. So square root of 7 plus 24i is plus or minus root over r means 25 plus a means 7 divided by 2 comma I times of root over 25 minus 7 divided by 2. So what about 25 plus 7? That is 32 divided by 2 is 16. So 32 by 2 is root 16 comma I times of 25 minus 7 is 18. 18 by 2 is how much? Root 9. What about root 16? Root 16 is 4. Root 16 is 4 and root 9 is 3. Therefore, square root of 7 plus 24i is plus or minus 4 comma 3i. Second question, find the multiplicative inverse of 7 plus 24i. So we have multiplicative inverse of z equals to a plus ib is z power minus 1 or 1 by z. So multiplicative inverse of z is 1 by z and multiplicative inverse of a plus ib is a minus ib by a square plus b square. So given complex number is 7 plus 24i. Okay, its multiplicative inverse is, that is 1 by z. Formula is a minus ib. 7 minus 24i, a square 7 sevens are 49 plus b square 24 square is 576. So 7 minus 24i, a square plus b square, that is 49 plus 576 is 625. Okay, or we can write 7 by 625 minus 24 by 625i. Okay, second bit also is there. So multiplicative inverse of sine theta. So given number is z is cos theta, sorry, sine theta plus cos theta. Z is sine theta comma cos theta is there. We can write sine theta plus I cos theta. So what about its multiplicative inverse? That is 1 by z is sine theta minus I cos theta, using the formula a minus ib by a square plus b square. A square plus b square means sine square plus cos square theta. What about identity? From identity, sine square plus cos square is 1. So sine theta minus I cos theta whole divided by 1. Simply we can write sine theta minus I cos theta. Now, third question is find the additive inverse of minus 6 comma 5 plus 10 comma minus 4. So first here two numbers are given, two complex numbers are given. We have to add the given two complex number. So what about z equals to? So actually given minus 6 we can write plus 5i plus second complex number is z minus 4i. Now addition of two complex number, so we have to add real term with real, that is minus 6 plus 10 is 4 and minus 5i minus 4i is plus I. So given complex number is 4 plus I. 4 plus I. Next we have to find additive inverse of 4 plus I. So if z is any complex number, the additive inverse of z, that is a plus ib, is minus of z equals to minus a minus ib. Therefore additive inverse of 4 plus I is minus 4 minus I. Okay, additive inverse of 4 plus I is minus 4 minus I. Additive inverse means just we have to change the sign of the given complex number. If any complex number in the form of A plus IB, then it additive inverse is minus A minus IB. Now next question, find the polar form of the following complex number. Polar form, as well as we can also call mod amplitude form. If A plus IB is any complex number, then its polar form is R times of cos theta plus I sin theta, where R is the modulus and theta is the amplitude. Okay, where R equals to formula is root over A square plus B square, and theta equals to tan inverse of B by A. So given complex number is 1 plus I root 3. So we have to convert into polar form, R into cos theta plus I sin theta. So how to find cos theta? So formula of cos theta sin theta as well as R. Formula of R equals to root over A square plus B square. So A means real part, coefficient of real part, or real part, that is 1 square, and B means imaginary part, that is root 3, whole square is 3. So what about 1 plus 3? Root 4, and root 4 equals to 2. So what about R equals to 2, and theta equals to, formula is tan inverse of B by A. B means root 3, A means 1. So theta equals to tan inverse of root 3. So tan inverse of root 3 means pi by 3. Tan 60 degree is root 3. So 60 means pi by 3. Therefore theta equals to pi by 3. So given complex number 1 plus I root 3, we can write R. R means 2 times of cos theta. What about theta? Pi by 3 plus I sin theta, sin pi by 3. So this is our required mod amplitude form or polar form. Now question number 5. Find the complex conjugate of 3 plus 4i into 2 minus 3i. So a complex number is given, we have to find its conjugate. If z is a plus ib is any complex number, then its conjugate is z bar, that is a minus ib. If z is a plus ib, then its conjugate is z bar is a minus ib. So z is given. So here product of two complex numbers are given. First we have to convert into, that is in the form of a plus ib. So 3 2s are 6, 3 3s are minus 9i, 4 2s are plus 8i, plus into minus minus, I into I square, 4 3s are 12. And what about I square? I square value is minus 1. So this will become 6 minus 9 plus 8i is minus I. Value of I square is minus 1. Already minus is there. So this minus become plus 12. So 6 plus 12 is 18 minus I. So our given complex number is 18 minus I, and its conjugate. What about formula of conjugate? That is z bar equals to 18 plus I. Conjugate of 18 minus I is 18 plus I. Complex number, second question. Under question number 2, our first question is, if z1 equals to minus 1, z2 equals to I, then find argument of z1 by z2. So we all know that if z is any complex number, that is cos theta plus I sin theta, 4 different conditions are there. If theta equals to 0, then z becomes cos 0 plus I sin 0. Cos 0 is 1, sin 0 is 0. So if theta equals to 0, then z becomes 1. Like that, if theta equals to pi by 2, cos pi by 2 plus I sin pi by 2, cos 90 is 0, sin pi by 2 is 1. So 0 plus I is I. If theta equals to minus pi by 2, cos minus pi by 2 also 0, and I sin pi by 2 is a odd function, minus I. So minus I. If theta equals to pi, cos pi is minus 1, sin pi is 0. So minus 1 plus I0 is minus 1. Therefore, if theta equals to 0, then z equals to 1. If theta equals to pi by 2, z equals to I. If theta equals to minus pi by 2, z equals to minus I. If theta equals to pi, z equals to minus 1. So here given z1 equals to minus 1. Minus 1 means our given theta is pi. And z2 equals to I means theta is pi by 2. So we have to find argument of z1 by z2. So first of all, we can write argument of z1 by z2 as argument of z1 minus argument of z2. And what about values of argument of z1? So argument of z1 for I, theta is pi by 2. z1 is minus I given, sorry. Z1 is minus 1. For minus 1, theta is our pi minus argument of Z2 is I given. For I we will get when theta is pi by 2. So pi minus pi by 2. 180 minus 90 is 90. That is pi by 2. Therefore, argument of Z1 by Z2 when Z1 is minus 1, Z2 is I is pi by 2. Now next question is question number 2. If z equals to 2 minus 3i, then show that z square minus 4z plus 13 equals to 0. So first write on the given. So given z is 2 minus 3i. Now we can write z minus 2 as minus 3i. Now squaring on both sides. So squaring on both sides means this will become z minus 2 whole square equals to minus 3i whole square. So this is in the form of a minus b whole square. What about formula of a minus b whole square? A square plus b square minus 2ab. 2 2s are 4z equals to minus whole square is plus, 3 3s are 9 and I square. And what about value of I square? That is minus 1. So z square minus 4z, 2 2s are 4 equals to minus I. If you take minus 9 inside, so this will become z square minus 4z. 4 plus 9 is 13. Okay, 4 plus 9 is how much? 13. Therefore z square minus 4z plus 13 equals to 0. Now question number 3. If root 3 plus I whole power 100 equals to 2 power 99 a plus ib, then show that a square plus b square equals to 4. So here root 3 plus I whole power 100 is given 2 power 99 a plus ib. We know that if z is any complex number, then modulus of z, mod z, is root over a square plus b square. And one more thing, mod z power n, we can write mod z whole power n also. So applying mod on both sides. If you apply mod on both sides, mod root 3 plus I whole power 100 equals to mod 2 power 99 into a plus ib. So this will become root a square means root 3 square is 3, b square is 1, whole power 100 as it is equals to 2 power 99 constant root a plus ib. Modulus of a plus ib is a square plus b square. 3 plus 1 is 4, root 4 is 2, 2 power 100 equals to 2 power 99 into root a square plus b square. Both sides 2 power 99, 2 power 99 get cancelled. One more 2 remains equals to root over a square plus b square. Now squaring on both sides. So square root of 2 square is 4. That equals to root cancel a square plus b square. Therefore the value of a square plus b square is 4. What about the value of a square plus b square? That is. Now question number 4. Express in modulus amplitude form. First bit 1 minus I. So given complex number 1 minus I, if you compare with a plus ib, a equals to 1, b equals to minus 1. We have formula of r. What about formula of r equals to? That is root a square plus b square is called modulus. Root over a square plus b square. So if you substitute the values of a square plus b square, so 1 square is 1 plus 1 square is 1. 1 plus 1 is root 2. Therefore value of r, that is modulus, is root 2. Now formula of theta is tan inverse of b by a. Tan inverse of b is minus 1, a is 1. So theta equals to tan inverse of minus 1. Theta equals to tan inverse of minus 1 means minus pi by 4. Now given complex number, we have to convert into modulus amplitude form. So r is modulus, that is root 2, and amplitude theta is minus pi by 4. Given complex number, we have to convert r into cos theta plus I sin theta, where theta is modulus, that is root 2 into cos theta. What about theta? Minus pi by 4 plus I sin minus pi by 4. Cos minus pi by 4 plus I sin minus pi by 4. Now second bit, what about second bit? Minus root 3, given z is minus root 3 plus I. If you compare with a plus ib, here the value of a equals to minus root 3, the value of b equals to 1. Formula of modulus r is root over a square plus b square, that is root 3 square is 3, b square is 1, root 4 is 2, and formula of theta equals to tan inverse of b by a, tan inverse of 1 by minus root 3, minus 1 by root 3, or simply root 3, 1 by root 3. So tan theta is 1 by root 3, tan pi by 6, but minus is there, so we have to subtract the theta from 180. So our theta is actually 1 by root 3 will come in trigonometry function tan, that is pi by 6, but minus 1 by 3 means we have to subtract theta from pi, pi minus pi by 6. So 6 pi minus 1 is 5 pi by 6. Therefore, if you write the given complex number in mod amplitude form, it will become 2 times of cos 5 pi by 6 plus I sin 5 pi by 6. Okay, so here we are getting theta is pi by 6, but minus is there. If value is minus is there, we know that from 0 to 90 all values sin cos tan will come in positive. If minus is there, we have to subtract the theta from 180 degrees. So 180 minus theta is 5 pi by 6. Now fifth question is, if z is cos theta comma sin theta, then find the value of z minus 1 by z. So first write on the given. Fifth question solution is, z is given cos theta comma sin theta. So cos theta comma sin theta, we can write cos theta plus I sin theta. Consider as equation 1. Then what about its multiplicative inverse, that is 1 by z is cos theta minus I sin theta. Okay, equation 2. Now adding equation 1 and 2. Now z minus, subtraction 1 minus 2, z minus 1 by 2, if you subtract, sign will change. Now cos theta plus minus get cancel, 1i plus 1i, 2i sin theta. Okay, z minus 1 by z is 2i sin theta. Similarly, this is our first bit. If, what about z plus 1 by z? If you do 1 z plus 1 by z, so sin plus minus get cancel, 1 cos plus 1 cos is, you will get 2 cos theta. Z minus 1 by z is 2i sin theta, z plus 1 by z is 2 cos theta. If z equals to cos theta plus I sin theta, then 1 by z is 1 by actually cos theta plus I sin theta. If you rationalize this one, so multiply and divide with cos theta minus I sin theta, cos theta minus I sin theta. Numerator becomes cos theta minus I sin theta, but denominator, that is in the form of a plus b into a minus b, a square. In complex number, always a plus ib into a minus ib is a square plus b square, that is cos square theta plus sin square theta. And what about cos square plus sin square is 1. Therefore, 1 by z becomes cos theta minus I sin theta. Okay. Then z minus 1 by z is 2i sin theta, and z plus 1 by z is 2 cos theta.